In this session, we shall be discussing how to find out LCM of three numbers. Let me start with the simple example. Say I have three numbers 12, 15 and 18. Now I want to find out LCM of these three numbers 12, 15 and 18. We have two methods as usual. Let me start with the first method, which is a direct method, where I have 12, 15 and 18. I'll take them together. I want to know if I can find any prime number that divides at least one of these three numbers. See, 12, 15 and 18 are those three numbers for which you can find a common factor 3. 3 is one such number which divides 12, 15 and 18 exactly without leaving any remainder. So let me start with 3. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. Now we have got the next set of numbers. Now this 4, 5 and 6, among these let me start with say 2. 2 times 2 gives you 4. 2 does not divide 5 exactly, right? So we will write 5 as it is. But 2 times 3 gives you 6. So we got our next set of numbers 2, 5 and 3. So 2, I'll start with 2 again. 2 times 1 gives you 2. But 2 does not divide 5, 2 does not divide 3, so we will keep them as it is. Now let me start with the 3. 1 keep it as it is, 5 keep it as it is because 3 does not divide 5, but 3 times 1 gives you 3. And let me start with 5. 1 keep it as it is, 5 times 1 gives you 5. So now that you have got 1, 1, 1 as the last set of numbers, you can stop this procedure here and you can say LCM of these three numbers 12, 15, 18 will be the product of those numbers, the prime factors that you have obtained to the left hand side. That is 3 times 2 times 2 times 3 times 5. The product of these numbers. Now let me write them in an order. This is starting with the lowest number first. So it is 2 times 2 times 3 times 3 times 5. That should give you 2 times 2 is 4, 4 times 3 is 12, 12 times 3 times 5 should give you 180. So the LCM of 12, 15 and 18 is 180 as when you solved it using the first method. Let me solve this using the second method, which is a method using the factor tree. So let me have the prime factors for 12. So we have 2 times 6 gives you 12 and 2 times 3 gives you 6. So the prime factors for 12 are 2, 2 and 3. So I can write 12 as 2 times 2 times 3. 15 I can write it as a product of 3 and 5. Both 3 and 5 are prime factors. So I can write 15 as 3 times 5. And 18, I can write 18 as 2 times 9. 9 can again be factorized as 3 times 3. So I can write 18 as the product of these factors 2, 3 and 3. So it is 2 times 3 times 3. Now how do you write LCM? LCM of these numbers will be the product of the prime factors repeated maximum number of times. Now you can see 2 times 2 times 3 in this you have a prime factor 2 which is repeated twice. In this you only have 3 and 5. In this you have 2 times 3 times 3. 3 times 3, that is 3 is a prime factor which is repeated twice. So let us write first 2 times 2 times this second set which is 3 times 3. You also have another prime factor 5. This is repeated only once. You obtained it only once. So we will keep 1, 5. right? So this will be the LCM. That is, you don't need to have any shared factor here. All that you have to do is to find out the highest power for each of the factors. So what are the factors here? 2, 3 and 5 are the factors you got. You're going to write the highest power for each of these factors, each of these unique factors. So you got 2 as a prime factor, that is repeated twice maximum number of times, so we are going to write 2 times 2. You have 3, this is repeated twice, so you're going to write 3 times 3. You have 5, that is given only once, so we have 5 ones. So LCM must be 2 times 2, that is 4 times 3 is 12, times 3 is 36, times 5, that should give you 180. You understand? Let us look at another example. Say I have numbers 28, 30 and 35. So how do you find out LCM? Let me start with the first method. 28, 30 and 35. Let me, oh, I'm so sorry. 35. Let me start all the numbers together. Now you know 28, 30 and 35. 30 and 35 are divisible by 5. 28 and 35 are divisible by 7. Both 5 and 7 are prime numbers. You can choose either of them. Let me choose say 5. Because 5 does not divide 28, I'm going to write 28 as it is. 5 times 6 gives you 30. 5 times 7 gives you 35. Now if you see 6, 7 and 28, let me start with 7 because 7 times 4 gives you 28 and 7 times 1 gives you 7. 7 does not divide 6, so we're going to write 6 as it is. Now you have 4, 6 and 1. Let me start with 2. 2 times 2 is 4, 2 times 3 is 6 and 1 as it is. And you can write 2 here. 2 times 1 gives you 2. Bring down 1 as it is. It does not divide 3, so write 3 as it is. And 3 you have 1 1 and 3 times 1 will give you 3. Now that you have got 1 1 1, we are going to stop the procedure here, and the product of the numbers that you have obtained on your left hand side will be the LCM of the three numbers, which is 5 times 7 times 2 times 2 times 3. Or if I want to write them in an order, in ascending order, starting with the lowest number first, it should be 2 times 2 times 3 times 5 times 7, right? That should give you 2 times 2 is 4, 12, 60, 420. So the LCM of the three numbers is 420. Let us use the second method, which is the factor tree method. 28, when I factorize this, I can write 2, this is, and 2 times 14 gives you 28, and this should give you 2 times 7. So the factors that you have are 2 times 2 times 7. So 28, I can write it as 2 times 2 times 7. We have 30 is 2 times 15, and 15 I can write it as 3 times 5. So the prime factors here are 2, 3 and 5. So 30 I can write it as 2 times 3 times 5, and 35 is 5 times 7. Both 5 and 7 are prime numbers, so I can write 35 as 5 times 7. So what are the unique prime numbers that you have? You have 2, 7, 3 and 5. Let me now check the highest power for each of these prime numbers. So I can write LCM as, first let me start with 2. 2 is repeated twice. In this case it's only once, in this case you don't have 2, right? So we have LCM 1, for 2 it is 2 times 2 because this is repeated twice. Let me start with 3. 3 is given out only once. I mean you have 3 only appearing only once, right? So we're going to write 1 3. Let me start with 5. 5, you have ones here, you have ones here, right? It's only one time that is being repeated. So I can write this as only one times, this is 5. And you have 7 also, this is also once, this is also once. So you can write 7 only one time, so you have 7. So you have written all the prime factors appearing in their highest powers, that is appearing in maximum number of times that it is getting repeated. So it is 2 times 2 times 3 times 5 times 7, which is the same result that you have got. So your answer is 420. So to calculate LCM of more than two numbers, it's quite simple if you do it in the first method. It's also quite simple if you do it using the second method. The only point you have to understand here is you're going to choose the highest power for each of the factors.